And as mentioned before, my name is Ryan Avitsky. I'm the STEM Center for Teaching and Learning Director of Learning, and I am humbled by your presence for our presentation today on the Foundation of Technology, Unit 1, Introduction to Computer Science Principles by Design. If at any moment you would like to follow along with our presentation, at the bottom of our screen, there's a bit.ly code that you can go through and follow along with or scan on the QR code. Our objective for today is to examine Foundations of Technology, Unit 1, Computer Science Principles by Design. The intended audience for Foundations of Technology overall is for grade bands 9 to 10, and it's for over the duration of 36 weeks. On our agenda for today, we're going to have a questions and comments form. So if you have any questions, you can make sure to place them directly in there, or as Rebecca stated earlier as well too, you can go through and email Rebecca directly, or you can even place it on our questions and comments form if you have any further burning questions that you just forgot to ask. Then we're going to overview engineering by design fairly quickly, talk about Foundations of Technology, Introduction to Computer Science Principles by Design described, coursework access, how do we access the content, the overall purpose of the unit, as well as Unit 1, Learning Cycle 2, Sphero board game construction, and Sphero and Onshape overall for Unit 1, as well as the future direction for FOT Unit 5A, Design with Onshape. And again, as mentioned before, feel free to scan below in regards to referencing anything as it relates to this presentation. If you have any questions or comments related for this presentation, feel free to go on this form and fill it out. That way, even if it's after our presentation and you're accessing it, you can always feel free to reach out to us. We're always here to help to serve you better. Well, first I wanted to start off by talking about what engineering by design is overall. It is an integrative STEM pre-K to 12 curricula that is offered to all students. It is built on the belief that the ingenuity of children is untapped, unrealized potential that, when properly motivated, will lead to the next generation of technologists, innovators, designers, and engineers. But why would we go through EBD opposed to other coursework? Well, we don't focus on developing children or students or pre-adolescents to become strictly engineers. We develop curricula to engage students to have the skill sets to be successful in the 21st century. So more effective problem solvers, analytical thinkers, critical thinking, and going towards those soft skills to make sure that whatever profession that student goes into, they're fairly readily equipped. Overall, iSTEM, or integrative STEM, is operationally defined as the application of technological engineering design pedagogical approaches to intentionally teach content and practices of science and mathematics education through the content and practices of technology and engineering education. iSTEM is equally applicable to the intersection naturally of learning within the continuum of content areas, educational environments, and academic levels. Long story short, we're taking all those disciplines and putting them together and blending them together to form our pre-K to 12 curriculum for engineering by design, and we're intertwining all those going towards the educational spectrum. EBD is built upon a consortium, and there's always 4 areas of focus that we drive our content towards. We are research-based. We work with several different National Science Foundations funded projects. We do research in regards to conducting it and how to perform or develop the best curricula to reach out to students. We are assessments-based. We offer pre and post assessments within each of our content areas. So 9th, 10th, pre-K, 6th grade, middle school courses. All of our courses have pre and post assessments built directly in there, as well as brief constructive responses, engaging technological and engineering literacy overall, multiple choice questions, essay-based, etc. We offer professional development and professional learning throughout the year. We offer summer institutes. We offer weekend workshops, and we are continuously here to serve you to make the educators or administrators or district supervisors or state leaders more affluent in understanding the engineering by design content overall. And we develop our professional learning to meet your needs based upon your time spans, availability, and monetary budgets. Engineering by design is driven through the standards for technological and engineering literacy, as well as the next generation science standards, Common Core, grand challenges for engineering, engineering habits of mind, and we're also aligning a lot of our coursework right now to the NAPTEL as well as the ISTE standards. So it'll cross from the STEL, the Standard of Technological Engineering Literacy, to the NGSS, Common Core, the aforementioned, as well as ISTE and the NAPTEL. All of our coursework is driven by a 6E learning by design model. Engage, explore, explain, engineer, enrich, and evaluate. Those 6Es drive our lesson plans, which then in turn are our learning cycles, or they could be knowledge skill builders depending on the grade levels, whether it's middle school or high school. We start off with the engagement portion to get the kids readily active to understand what the content is going to be learned about, because we're always going towards student learning connected to our objective, which is also driven from our standards. Exploring, which is really a phase to provide students the opportunity to construct their own understanding of the topic, because we want student learning to come first. So student-led instruction. Explaining, so going through an overarching explaining that and providing students the opportunity to refine what they've learned so far. Little e, engineer, which is more so an extension or elaboration on that content overall to enhance their learning. So bringing that project-based learning directly to life. So learning a mathematical concept and then afterwards going through applying it, which we'll talk about a little bit later, shown through our content. Enrichment, the purpose of it is to provide students the opportunity to explore in more depth what they have learned and to transfer concepts to more complex problems. Evaluation is going towards an assessment phase for both students and teachers to determine how much learning and understanding has taken place. Again, focusing on learning, not student doing. As mentioned before, we are pre-K-12 curricula offering from pre-adolescence all the way up to 12th grade. So we have elementary content, pre-K content, middle school, as well as high school content overall. It is not to say that if you don't take our middle school coursework, you won't be successful at our high school coursework. It is recommended, though, that you build a pathway to gear the students up to be readily prepared for the STEM content delivered at the next level. But if you don't take technological systems, for instance, that isn't to say you can't be successful in foundations of technology. They don't build directly on one another. We build skill sets within each individual grade level that we know the students are capable of accomplishing because our content is equitable, achievable, and reachable for all. In order to become an engineering by design school overall, and to access our MRE or Media Rich Edition version on a yearly subscription basis and is delivered from our learning management system, you can access this directly through your overarching site, which is found on ita.org when you go to your STEM by state and you choose your individual state. Teachers using the EBD Buzz are required to administer the online pre and post assessments. This allows you to get diagnostic knowledge on your students to measure their growth throughout the course of a school year, and this is provided in each middle school and high school course. And if you can't get access into our LMS, we do provide common cartridges to help to transfer over to your LMS to make it user-friendly across any portal. Foundation of Technology, if you've been teaching it before or now, it is built around preparing students to understand and applying technological concepts and processes that are the cornerstone for the high school technology program. So this, again, it's reaching out towards that 9th to 10th grade level students. We've also seen success FOT taught in the 8th grade as well. And this is really built around trying to get group or individual activities to engage students in creating ideas, developing innovations, and engineering practical solutions. So as we mentioned before, this isn't necessarily built to gauge the students to become engineers. We're trying to get them to form practical solutions, how to solve everyday problems, and how to be more innovative to make changes for the better good overall. This is done through problem-based learning and project-based learning by delivering technology content, resources, as well as laboratory and classroom activities for student applications on the integrative STEM disciplines. Foundation of Technology, the unit described. So there's an ever-growing demand as we move further into the 21st century for students to understand the concepts behind coding and also not really be afraid. Coding can be kind of scary at first, so we're trying to engage the students in a way that we use problem-based and project-based learning in order to engage the students to apply the coding concepts. Similarly, when students learn a mathematical concept such as Pythagorean theorem, and then applying it in Foundation of Technology towards a crane strain, this unit really goes through and details how to take a coding concept or learned concept and apply it towards a further learned problem. You'll be utilizing block coding, script coding for enrichment exercises. So what that means is we're trying to engage all students. We're offering the option or the autonomy to go through block coding as well as enrichment portions for JavaScript, which is built into the content overall. Students will also explore three-dimensional modeling that will integrate into their robotics projects. So the overarching purpose of Unit 1 is for students to learn computer programming concepts, as mentioned before, through coding and script for enrichment exercises. Through the unit, they'll be utilizing the Sphero technology to learn coding concepts while using the engineering design process to solve programming challenges. So as I mentioned before, the sole purpose behind this unit is to use the engineering design process to solve problems through coding and then do applied learning concepts. This unit is a phenomenal segue into the Computer Science Principles by Design course that Engineering by Design also offers, that is AP aligned and is also offered for utilization through any school district, state or internationally. The students will also learn to use spatial reasoning while demonstrating the understanding of the capability of an overarching robotics system.
All right, hello everyone. As Rebecca mentioned earlier, I'm Brad Fessler, and I am working on the update to Foundations of Technology for Unit 1. So I'm going to go through some of the new updates with Learning Cycle 2 and Learning Cycle 5 with you. So as Ryan mentioned before, we have the 6E lesson plan. So in Learning Cycle 2, which is developing a board game using a Sphero. So for the engage portion of this, students are able to view a presentation in a video format, which is created by the author of the curriculum. The nice part about this is you're able to go through this curriculum in a flipped classroom setting. So for instance, the linked file that's here, when we click on that file, it'll take us right into a video that the students can go through and actually watch that presentation as if the teacher was delivering the presentation live in the classroom. So then moving through that lesson plan, in the explore stage, students will go through and document everything through their engineering design journal. They'll define all the problems that need to be solved and the overarching problem as well. In the explain portion of that lesson plan, the teacher delivers instruction about the variables using a presentation, which is set up in a PowerPoint format. If students are learning this in a flipped classroom experience, they're already seeing that presentation delivered via the video that I just showed you a brief moment ago. And then they're also seeing the requirements of their solution to this problem, which is in a rubric format, which is also a linked document. So for instance, we'll open up this document, a preview here, and in here, the students are creating a board game that simulates the rolling of a die. And they're building every other aspect of the game. So they're developing the rules, the board, any additional pieces like characters, tokens, play money, whatever that might be with that, with their design. Then in their program, they're going to create a program with the Sphero to simulate rolling of a single die. So that program must sense that the robot is being shaken, and then generate a random number 1 through 6, and then convey that number back to the user. And there's a couple ways you can do that. You can do that using an LED matrix, say on the Sphero Bolt, for instance. You could do it through the speech options that are in there, or you could simply blink the LED that's on the Sphero as well. The students are required to create a variable to store that random generated number. They also have to create a function that they call dice roll to generate that random number and output the number to the user. Again, like I said, you can use speech or strobe commands as well, and you must provide feedback to the user. So in this case, we'll make the Sphero vibrate by using the raw motor movement control systems right within the Sphero coding. So let me just show you what that actually looks like here. And jump back to my video here just a second. So here I have my Sphero robot. And when I run the code that I've generated for that, so now my Sphero, it's hard to see on the display here because I can't necessarily turn it very well, but right now my display is green. And when I shake that,
you roll to 6.
So the Sphero is actually giving me 2 outputs. It's blinking the matrix red once for every number, and then it also outputs sound through the programming device. So in this case, I'm using my computer. So my computer is speaking that. So I'll turn my volume up a little more, and I'll do that one more time.
You roll to 2.
So you can kind of get that user feedback from the Sphero as well, which is a really cool feature within their program. So let me share my screen again, get back to that presentation. All right, so the students will design that board game. This is in the engineering portion of the lesson plan. They'll design that board game utilizing the roll of a die. The Sphero robot is simulating that. They're documenting everything in their engineering design journal. One thing that I think is crucial anytime we are planning a coding kind of project is to have the students write some kind of pseudocode. So that pseudocode could be the actual commands that are available in the software. In this case, we're talking about the Sphero EDU app. So they could be writing down those block code commands, or if they're a little more advanced and using the enrichment part, which I'll get to in a minute, they're using JavaScript. They could be writing the actual code on paper the way they think it is going to work. Or they could be writing in plain English just how this is going to work. So the kind of that workflow of the program. Students then code their solution using either block coding, or if we're under the enrichment task, they could write it using JavaScript if they're a little more advanced in coding. And then under the evaluate portion, student solutions and execution of their design process are graded using that same rubric that we saw just a moment ago. So that's learning cycle 2. Learning cycle 5 of that unit is Sphero and the integration of Onshape. Onshape is a online CAD software, which is free for education use. And we have developed a way to integrate the Sphero lessons with Onshape. So in this particular learning cycle, students will develop using Onshape, a particular Onshape file, which I'll demonstrate here in just a moment. They'll develop an obstacle for their Sphero to have to navigate. So going through this lesson plan real briefly, you'll notice that there are 2 videos that go with this. One is the presentation, which you have in the explain portion. And the second part is specific to how to utilize that Onshape file, which is made public in the Onshape system. And then the students will brainstorm and sketch their obstacle once they've taken a look at their configuration file, and then they'll move through the rest of the steps going through there. This particular assignment, this learning cycle, is really, really neat because the integration of the CAD system and coding, they really flow well together. As you'll see in this video, if you take a look at that file 1.5.3, it shows that you're actually using coding concepts right inside the CAD software by putting variables in place in your CAD software. So more details on that, you can see there are multiple types of configurations here. So this top right one, we have an archway that is pre-built, and the students customize that in their configuration panel. And then at the bottom, you can see another one, which is kind of a seesaw type or balance beam type obstacle that the students would have to program their Sphero to get over that obstacle. And as I mentioned earlier, there are videos for all of the presentations and other instructions so that you can deliver the content in a virtual or flipped classroom approach, which is really, really nice. So I'm going to jump to another tab here for just a moment so that you can see my CAD file here. So right within, sorry, I got to get out of full screen. So right within Onshape, and this file is open to the public, so you can actually pull up this file right now. You can search under the public side once you log in under your account, and you can search in here EBD FOT Unit 1 Learning Cycle 5. Notice they're abbreviated, and click search, and it'll take a moment till it loads that file. And inside of there, we can open up that file. Now, what you're seeing right now is a read only, so it's a view only file. You can actually go through and change the configuration right in here, but it really doesn't allow you to save that workflow. So students will want to click make a copy so that's available there. And here you can see the different obstacles that are pre-configured for you, pre-drawn in the CAD software. So you can do rounded bumps, offset rounded bumps, triangular bumps, offset triangular bumps, an archway, and a seesaw. So let's take a look at the offset rounded bumps. And I'm just gonna zoom to fit here so we can see. And I can change the radius of those, and you'll see that they get smaller. I can change the spacing of them here to bring them closer or spread them further apart. I can change the number of bumps that I want here. So you can see how that CAD file will automatically adapt to these configurations for you. So let's take a look at the seesaw, just to give you one more example here. And I'll do a zoom to fit so we can see that. So we can change the length of that seesaw if we want. Oops, sorry, that was the width of that seesaw. 10 inches will be really easy to work with if they can navigate to that, right? And then let's make the length also 10. So you can see how that would automatically adapt for you right in the CAD model. And then right here are your part files. You're actually able to download these part files right from here as an STL or OBJ file, depending on what you need for a slicing software. And you could actually 3D print your parts right here, right from the CAD system. So the students are getting their first initial taste of the Onshape system, so they can kind of get their feet wet, but not have to know all the ins and outs of sketching and extrusions and really building a detailed file. So that's the Onshape portion. And let me jump back here to present mode. All right, So kind of the future of FOT and Unit 5, Unit 5A, which we're titling Designing with Onshape. So Unit 5A will be created to provide students with a strong foundation in computer-aided drafting and design using Onshape. So students will be prepared after this unit and additional instruction. Will be able to go through and will be prepared to take and hopefully pass the Onshape Certified Associate exam. This exam is an industry recognized credential in several states. I know personally in Pennsylvania, I'm already pursuing that it's an industry recognized credential for my particular school district. So my students can take this exam and earn that industry credential while they're still a high school student. And there is a link here if you do want to check out the link to the exam. There is a cost to the exam as of right now. I believe certain states we're working on some programs there to maybe help with that. Feel free to reach out to Ryan or myself and we can help you if you're interested in that. And again, the objective, which I know Ryan had briefly mentioned for this, Unit 1, Principles of Computer Science, Principles of Design, we're looking for, high school students and educators, grades 9 through 10. The course length itself for FOT, moving through all of this is about 36 weeks to move through.
All righty, well, thank you, Brad and Ryan. Is that everything you have for us today for your presentation? And we can move on to Q&A?
Yep.
Perfect. So just as a reminder, if you have any questions at all for our two presenters here, you can ask them at any time by submitting them in the Q&A box down below, and questions will be answered in the order in which they are received. So our first question, by the way, I just wanted to mention, thank you for that demo. That was a really great demo that you showed. And also, I thought that was really great to prep for the Onshape exam. I really like that. So regarding Onshape, what's your rationale behind showing how the code within Onshape and applying it to those rendered models that you showed us?
Okay, so coding within Onshape really allows you for flexible design. So, it really shows students that you can take the computer coding concepts and those computer science concepts and apply them in a variety of industries. It's not just, to code this nifty little robot. You can do a bunch of other things with it. So right inside of Onshape, it allows you to set variables and bring those variables and set them as dimensions and other things right inside of the design software, which allows that flexibility. It allows us to do those configurations where the students can just select, or the end user can just select, oh, I want this radius to be a certain size. So you can just type it in and not have to go back and edit all of the other design features and dimensions.
Thank you for that. We have a question in the Q&A box. Are there recommendations and suggestions to help educators deliver this Foundations of Technology and Engineering unit in a virtual world?
It's a great question. The reason I say it's a great question is that we don't know where we're going to be, right? We don't know where we're going to be tomorrow, next week, a month, a year from now. So the direction that we've decided to go through the STEM Center for Teaching and Learning is to prepare our content to truly reach for all in every situation. So as Brad was mentioning in the FOT unit for Unit 1, as we expound upon that and innovate what's currently there, is that it's all made in a hybrid format, whether it's if you're teaching from a distance or whether you're teaching physically or whether you're teaching anywhere. If a student wasn't able to be there in the classroom, maybe was ill, we're really trying to design our content in a way and be very cognizant of that new student and that future student. So it is actually being built in a virtual sense. And as we design Unit 5A for designing with Onshape, it is built in that virtual sense delivery as well too. So every revision actually that we've gone through so far throughout the course of the 2021 school year is truly in a response to what's being asked for, is that what hybrid resources do we have, or what are we doing to engage the teacher that has to teach from a distance. So you'll see more and more frequently, especially with the release in the 21-22 school year, several courses, and we're continuously updating our coursework to be reflective of that hybrid format, virtual deliverance, or physical delivery. We also do offer to our student-facing courses such as Foundation of Technology Online and Engineering Design Online. But in addition to that too, we are even enhancing and ramping up our online version of FOT. So that's another project we're working underway that's specifically towards that virtual digital learner. So as we have our hybrid physical and virtual deliverance of our FOT, we are also making a direct sole one towards that virtual learner as well, student facing.
So would there be any key differences, or would it look pretty much the same if a school starts out as, say, virtual and then moves to hybrid, or starts out as hybrid then moves to in-person? Are there any differences between any of those formats, or is it catered to pretty much all accessibilities?
Great question as well too. So as you see a specific course that's deemed FOT online, that is directly around that student facing, it would best serve around that virtual learner. So the student is learning 100% from home and maybe has an educator overseeing the work being done and turned in. The FOT Foundation of Technology course, which is actually turning into, as we're innovating it now, to Foundation of Technology and Engineering, because we're moving toward that direction for the 21-22 school year overall. You'll see that course that's being able to be actually taught in the hybrid format, physical or even virtual sense. So one that's truly significantly intentionally built towards that virtual learner only. Another course built in a way where it's physical, virtual, or a hybrid format if it gets up and down. So you have both resources for access at your tool belt or arsenal.
Great, thank you. Can you talk a little bit more about the flipped classroom video that you had mentioned earlier? Who would that be for? Would that be for students who are learning at home? Would that be for the teacher to hear more about the lesson? Can you expand upon that a bit?
Okay, so the flipped classroom videos, those kind of presentations in a video format, they can be used in a multitude of ways. So if you're familiar with a flipped classroom where students are doing that kind of instructional type learning on their own time or outside of class time, that way it leaves more time for the hands-on experiences in the classroom with the student and the instructor together. Or if we're talking about a virtual setting, that time where they're together in some way, even if it is virtually, to be able to answer questions. That's kind of one of the main focuses, but it can also be used as kind of a practice tool for the teacher to be able to deliver their presentation, making sure that they're hitting that essential content and getting a deeper understanding of what that presentation is really there for. So although they're published in our media rich edition as a student resource, they really are a resource for anyone involved in that particular instructional unit. So those videos are a great tool for both instructor and student alike.
Sounds very multifunctional. Let's see. So how is the FOT unit, the Introduction to Computer Science Principles by Design, is there a connection to the EBD AP Computer Science Principles by Design at all?
Yes, and a phenomenal question as well too. So we intentionally are looking towards developing that overall learner. So we're developing this unit to be that segue or pathway. So if a student chooses the next level and says, hey, you know what, I'm also a little more interested in computer science, I want a little more about coding. So the FOT unit An FOT overall is supposed to actually give a touch or feel on manufacturing, a touch on coding, a touch over here. So it touches on multiple different learnings and practices and contexts as it relates to the STEL. And after they get a touch on it, say, well, I'm really interested now in this coding. It's actually built in a way that segues really well into computer science principles by design, the AP course. And how we actually do that as well too, is that we embed and use Sphero technologies throughout the entire Unit 1. We also offer the autonomy within the Unit 1 too with microbit technologies, which is actually integrated and utilized in the AP Computer Science Principles by Design for that hands-on approach. And that's called an ITA kit. So we integrate that actually within our Unit 1. So the direction, and to kind of expound upon that a little bit, the direction with all of our units and revisions that we do for moving forward purposes, we're going to have one direction where you're able to utilize particular technologies if you have the resources and monetary expenditure and funds available. So the Sphero technologies are highly encouraged, to use our Unit 1 because they embrace block coding as well as JavaScript. We also offer the option for the microbit processing chip. So you get the exposure through that Unit 1 and is built in a way to get you ready to go to that next level, which the AP course, AP Computer Science Principles by Design, which is directly built around SNAP. So we feel the STEM CTL that block coding helps to build a good segue for the SNAP coding. And whether using Sphero technologies or the microbits, they both get you readily prepared for that next level. In addition, we see the growing need and demand for focusing on future AP courses. So for instance, we're gearing the students ready to go to the principles course because we're introducing block coding as well as Java to go to the principles course by Design AP. But the next level is there's an AP Java course. So in our FOT unit, we're also trying to get students a little bit of touch in that enrichment portion in our 6Es. Say, well, I love the coding. I want to go to AP Computer Science Principles by Design because that's first. And then afterwards, go to AP Java. So the learning snippets in that first unit that kind of gear you up for the next 2 years for success. So it's definitely a great segue and it's intentionally put in that direction. And to tack on to that, we are also in the process after finalizing this unit within FOT, which is actually going to be key turned over to FOTE, Foundation Technology and Engineering. In our 8th grade course, we will be building another unit specifically around an introduction to computer science code and to really get those students ready and excited to take it to the next level with AP courses and also make them less afraid and get them up ready for that next level at the high school area.
Well said. I do have a question here, but I think you might have mostly touched on it. How do you believe the Sphero integration within the content will inspire students to become future innovators and problem solvers? I know you touched on good preparation for AP Computer Science Principles and computational thinking. Is there anything else you wanted to add on to that at all?
Brett?
Yeah, so students throughout these 7 activities, individual activities in Unit 1A in FOT, they're going to be getting a great foundation on just programming basics. So talking about logic and comparators and the mathematics involved in programming. Although it's not a full-fledged programming course, this gives them the basic structure of how to build a computer program, whether it's using JavaScript for our enrichment, or it's using that block coding concepts to be able to kind of design and understand how a computer program works. They're getting those foundational skills, in those 7 learning cycles.
Awesome. Let's see. Thank you for that. Do you have any ideas to help educators differentiate this course for students that need extra help? Let's say, as an example, if they're on the autistic spectrum or if they have a specific 504 plan?
Well, specific 504 plans speak specifically to the child. So we do build our courses that are built in a way that are accessible and equitable for all. So it allows for scalability. So for instance, if you have an individual lesson that's built around the coding areas, then you can scale it down to meet the child or student's needs. but we would be able to specifically adhere it or to tailor it into our coursework to a specific 504 plan, but it's scalable because engineering by design doesn't force anybody to teach a content a specific way, but you can use the litigations and legalities that are written in the 504 or the IEP around that student to be able to actually differentiate and use your strategies that are employed with the IEP plans or 504s, because 504s and IEPs are written specifically and individually within the school district as well as the overseeing county or state. So you would adhere to the IEP or 504s, and then you could scale our coursework based around adhering to those litigations that are written in the 504 IEPs, because we don't enforce the content. Some content areas, some other organizations or businesses or contents deliverers say, hey, you have to teach it this way, but we're not actually saying that. What we are intentionally doing, though, is we are not only trying to reach that hybrid format. When we're developing these videos, we know that students are audio, they could be visual, they could be hands-on. So when we're talking about hitting different spectrums of learners or applied learning learners, that's where integrative STEM kind of comes into play. So for integrating, hands-on learning to reach out to that other side learner or to different learners, we're incorporating different disciplines, or incorporating all these strategies to teach any student. These videos are also made in the sense that a lot of the times, I just speaking from administrative experience, I've always asked for audio or audio visuals. So now we're having multiple different resources and not just used for a hybrid format, it can also be used for a child. So I know, for instance, that some IEPs may call that someone has to record, what's being taught. And that might be in an IEP specifically listed or a 504. So we have those recordings available too, because I saw that quite often, just speaking from my personal experience. So we have that coming into play. We have the different resources that actually talk through an activity. So a lot of the times, sometimes if it's a co-teacher or teacher model, you have an activity, but the student may need it read to them. So we do have individual videos that literally go through and they slowly detail and talk about the activity to the child. So they'll have these additional resources. So although we can't specifically address every single individual need, our course is equitable and achievable and reachable by all, so you can scale it to meet and adhere to those 504 and IEP regulations. But in addition, we also have all those additional resources built within the content that you can use at your arsenal now that were not there and aren't prevalent in a lot of courses.
So just to summarize, there's many audiovisual methods of utilizing the curriculum, right, Ryan?
Yes.
And it's flexible, so you don't have to adhere exactly to everything that FOT&E lists out. You can kind of branch out based on the needs specific to your classroom.
Yes.
Okay. Does Sphero allow the curriculum that coincides with Sphero? Does it allow for that as well?
Yeah, absolutely, it does. You can always scale any of these activities to a point where you can take some of the requirements out of an assignment to make it a little easier to build that program for a student that may take a little more time to build a program. And the exact opposite is true with any of these activities. You can go away from the block coding concepts and move into JavaScript for those students that are maybe a little more advanced and got through the block programming, in half the time. Well, they can use that additional time to go through and learn to program it in JavaScript.
Perfect, thank you. We have another question here. The programming language that you use in AP Computer Science Principles, is that Scratch or Snap?
In the AP Computer Science Principles by Design, we specifically use Snap programming, which is, we feel, a level above Scratch. So that's why we are intentional on using block coding via Sphero technologies, as well as the different alternative, the ITA portion, which is the microbits, to help to gear students up to be ready to go towards Snap programming. So we use block programming within, as Brad mentioned, in this coursework, which also we offer the Java, to get them readily prepared for using Scratch Snap programming in AP CSP by Design.
Alrighty, let's see. How do you feel about using coding principles to inspire future designs?
So, coding principles, like I mentioned earlier, fall into all kinds of categories. It's not just developing computer applications. As you saw, earlier, I talked about you can use variables right inside of Onshape. Another cool thing in Onshape, you can actually code your own features right inside of Onshape, which is something that I explored as I was developing curriculum, and with the help of some folks at PTC, the developers of Onshape, and they went through and guided me through how to code my own features and how to create things and how to create those configurations. So coding, took a product which is already out there and allowed me to modify that product to do exactly what I wanted it to do in a pretty user-friendly way, just by learning some of those coding concepts. So that was on kind of a development side, but on the user side, you can see right through the file that I used in this demonstration where those coding concepts are put to use right in there from a user aspect, not just a developer aspect. The coding concepts aren't going anywhere in our everyday life. I'll share a quick real life story. I was just at Hershey Park the other day, and I'm waiting in line at a ride, and inside of a clear box, they have an Arduino, which is something that we teach in multiple ITEA engineering by design classes. And that Arduino was used for what they term as their fast track. So you wear like a wristband and you can scan it, and it basically checks a database. And does that person have a fast track pass for that ride at that particular time? And that all that processing is happening through a little, microcontroller that's about $20 or $25. So they're using these same technologies that we're working with our students in real life applications. It's not going anywhere.
I like that real life experience that you have there. I'm not seeing any other questions in the chat. Before we head out, and if there's any other questions, please feel free to stick them in quickly. But as a final note, if you have any key takeaway about this course, or if a teacher wants to bring this to an administrator to ask them to put this into the classroom or build it into the curriculum, do you have any pitch that you can share that a teacher would want to share with an administrator for why this would benefit their classroom?
For sure. We offer a equitable, achievable, and accessible content that reaches all learners, and that is a cost-friendly and very, very user-friendly content that is constantly innovated by ITEA and the STEM Center for Teaching and Learning to reach the 21st century learner.
Well said.